Today we're going to go over the power rule, which is a way to derive a polynomial function. And a polynomial function is a function in the form x to the power of n, where n is a constant. So let's go ahead and look at this limit. This is the formula for the derivative of f of x. You may have heard of this, you may not have, but it is very tedious and annoying. And you'll no longer have to use it because, or at least you won't have to use it for polynomial functions, because we can use this equation over here, which states that the derivative of x to the power of n is equal to n times x to the power of n minus 1. And this formula, or I suppose this equation, proves why the derivative of a constant is 0 and why the derivative of a constant times x is equal to that constant. And let's go ahead and give you an example as to why that is. So let's say you're trying to find the derivative of 3. Well, as you know, x to the power of 0 is 1 because anything to the power of 0 is 1. So another way of writing this is by saying 3 times x to the power of 0, because that is still equal to 3. And using this equation, we can we can take out the 3 and multiply that by the exponent of x, which is 0, times x to the power of -1. And anything multiplied by 0 is 0, and that is why this is equal to 0. So now let's go over why a constant multiplied by x to the power of 1 is just the constant. First, we're going to write down the 3 and then multiply by the exponent of x, which in this case is 1. So 3 times 1 times x to the power of 1 minus 1, which is 0. And this is equal to 1, this is equal to 1. So 3 times 1 is equal to 3. And that is why a constant times x to the power of 1 when derived is equal to the constant. Okay, this is example problem 1. You may have noticed that this isn't really in the x to the power of n form. Fortunately, we can change it so that it is. So we're going to write the derivative of 2 times x to the power of -1. Because keep in mind, you can switch a variable from the numerator to the denominator, or the denominator to the numerator, by changing the sign of the exponent of that variable, or whatever number it may be. So that's why this is equal to this. Now we just have to find the derivative of this. So we're going to write out 2 times the exponent of x, which is -1, times x to the power of -1 minus 1. Now this is equal to -2 times x to the power of -2. And this is equal to -2 over x squared. Okay, this one looks a little bit difficult, but it's pretty simple. It states that y is equal to 1 over 4 times x cubed minus 6x plus 3. And now we have to find the derivative of that. First, we're going to just focus on each individual term. So first, let's focus on 1/4 times x cubed. We're going to write out 1/4 time. We're going to bring down the exponent, which is 3, times x 3 minus 1, which is 2. Now let's focus on this. As I said earlier, the derivative of a constant times x to the power of 1 is just that constant. So that is -3. And now we have to find the derivative of 3, and the derivative of constant is 0. So now we can just simplify this. We can say that 3/4 x squared. And that is the derivative of y.